what we are doing today is we are going to be continuing on with chemical reactions. Okay, we're continuing on. You will need your Unit 7 notes because we are covering the ionics, and you will need your solubility charts and all those kinds of things. That's in your reference packet. So you will need your solubility chart and your oxidation chart in your reference packet. So have those earmarked. And then if you have your notebook that you take all your notes from class in, or scratch paper, because I want you to physically work these out, because these are the type of problems that you cannot do in your head and get them 100% right every time in the beginning. Even people like, I mean, you guys have heard me make mental errors and whatnot, and that's normal because your brain skips stuff and it's part of how memory works. So make sure you're writing stuff down. So the first thing we're going to do is a review part. So we're going to take this problem, that's the warm up, and we're going to build the balanced equation, which is something we've been doing during stoichiometry this whole time, right? From that equation, I'm going to show you how to get a net ionic equation, and I'm going to show you how to get a spectator ion and what all that means. And then after that, you guys are going to practice on your own. And if you get it right, you can go. And if you don't, you stay. Okay? That's at least until you get it right, and then you can go. So we're going to start with this guy. I have the wheel up, the magical wheel of names. So excited. So I let most people join. Let's see. Okay. Open. See, it's still doing this. Still doing that. It's like grayed out and like, by the way, I know you want to use me, but you can't right now. It's like the little wheel, thinking wheel. It's really lame. So I'm just going to call on random people to start, and then I'll start the wheel. I'm going to go in order that I see them on my screen. So Darshan, you're the first block on my screen. Welcome. This question says, solutions of potassium phosphate and zinc chloride are added together. What is the balanced chemical equation? So if you were in the laboratory and we were watching Darshan do this, what would you be doing right now?
I would first circle potassium phosphate and zinc chloride, and then underline that they're added together. And then it's asking for what's the balanced chemical equation.
Yeah, potassium phosphate and zinc chloride. And the very important part that you highlighted so well is the are added together. So in the lab, that means that you're measuring out potassium phosphate, you're measuring out zinc chloride, and you're putting them together in a vessel to watch what happens. So are these both reactants or products?
They're both reactants.
Okay, the wheel is now loaded, so you may get called on twice, but that's okay, friend. You'll be all right. So Sia, all right, Sia, S-I-A, Sia. How do I start? What do I do now?
So first, what I did was I wrote the compound of potassium phosphate.
Okay, so potassium phosphate. How did you write it?
So I got K3PO4.
Okay, so can you remind the class, for people who are not as high speed, low drag as you, how you got that K3PO4, because it is correct and beautiful. I just want you to tell everyone how you got it.
Yeah, so we know that there's a potassium, so I looked at my oxidation numbers and I saw that potassium had a charge of 1+. And then I looked in my reference packet for phosphate and I saw that phosphate had a charge of, 1 second. Okay, yeah, so phosphate has a charge of 3-. And then to like balance it out, you need to give potassium 3 so that it's like 3+ and then 3-.
Yep. Because 1 times 3 is 3, 3 times 1 is 3, positive, negative, need to add to 0. Love it. All right. What phase is this?
Aqueous.
Yes. How did you know?
I used my solubility rules.
You used your solubility rules, which is fabulous because potassium is a group 1 salt. Is there another clue you could have used?
Oh, solutions, the word solutions.
Yeah, the word solutions always means aqueous, right? So both of these are going to be aqueous because we have solutions of them. I see my chat blinking. I want to make sure it's not. And now, just to be clear, there are a couple of you that are coming in. Yeah, Sangeet, that's good. There's a couple of you that like have missed class because of like quarantine or whatever else. And so some of you may be spotting behind. That's why I'm making sure that we explain every step really well, because there are people here that haven't been here in a while or missed like a day here and there. So we're using a comprehensive review. So if I ask you to be really detailed, it's so you can help your friends and we can all remember together. Okay. All right. It's not me just being annoying. So I may be being annoying, but it's not intentional to be just annoying. There's a purpose. All right. So next, you did a great job, Sia. Shanmathi, can you do zinc chloride for me?
Yeah. So zinc is Sn and it has a charge of 2+. And chloride is Cl and it has a charge of 1-.
So how did that go together?
It would be Zn, 1Zn for 2Cl.
Yes, because we need 2 -1s to balance out the 1 +2. And what phase state is that?
It would be aqueous.
Yes, and you could tell by your solubility rules chart, which we already referenced, or the fact it says solutions, which is plural, which means both of them are solutions. All right. Awesome sauce. You guys are killing it. All right. Next up in the moonshot factory. Okay. Drum roll. Manahil.
Yeah, that was good.
Win for the day. That's my exciting thing for the day. All right. What do I do now? I put both my reactants down there. What do I got to do?
So now you have to find the products, and I don't know what the reaction is called. Sorry, I forgot. But it's like where they both split up with each other and then go with the other people. A double replacement reaction.
Yeah, there we go. You described it perfectly, so I knew it was in your brain space. This is a double replacement reaction because we have 1, doesn't matter how many of them, 2, 3, 4 different groups of ions. So the number of ions you have, 1, 2, 3, 4. If it's 4, that means it's 2 couples and they do-si-do, right? So what happens is phosphate and potassium break up, and phosphate's like, fine, I'm going to hang out with zinc. But now chlorine has no one to hang out with because phosphate took zinc. So chlorine's like, fine, you didn't want potassium anyway. I'm going to go hang out with potassium. And that way that they're replacing each other, which is where the double comes from. Awesome. So you did a great job. And I did a great job saying your name. So I'm excited about that. I'm going to pat myself on the back and be not humble for a sec. It's so hard. All right, Maheen. So now that we know it's double replacement, how do those mix up and go back together?
Hold on, I don't really remember.
I know, and I'm pulling on you because you're one of the people that hasn't been here in a while. Like, why couldn't I have called you earlier when it was ion stuff, right? I'm just kidding.
Yeah, I'm sorry, I completely forgot. I'm trying to go through my notes.
You want a hint? Since you haven't been here.
Yeah.
So the double replacement, we know that the nonmetals are replacing each other, that the back ends are switching. So potassium is going to be with the back half. So like so when we're doing double replacement, it's the two, I didn't mean to draw there. It's the 2 back ends that are switching with each other. So chlorine is going to end up with who?
Chlorine's gonna end up with potassium.
And then phosphate's going to end up with who?
Zinc.
All right, so let's do that. So let's focus on the potassium first. So I know I have potassium, and it's going to be with who?
Chlorine.
Chlorine. So potassium is a charge of 1+. We see it right here. Chlorine is a charge of 1-. So what proportion do we need for those?
It's just 1 and 1, right?
It's just 1 and 1. What phase is this going to be? Now, it didn't tell us anything about the reactants in the problem. So where do we have to go to figure out the phase?
The solubility chart?
Yes. So when you pull up the solubility chart, there are 2 different rules that apply. I already have them highlighted because we talked about this earlier in other class. Group 1 is potassium. Chlorine is in there. both of those show me that it's going to be aqueous because the exceptions aren't true here, right? So in the solubility chart, it's going to be aqueous. Awesome. I'm going to pick on someone else now. You did a good job. All right, Esty, finish it off. Who do we have now?
Next we have, wait, sorry, I'm a bit lost.
You're good. We already used potassium and chlorine in our reactants or our products, right? So who's the only people left?
Oxygen and zinc?
Zinc phosphate. The phosphate's part of that group there. See how it's
Okay.
yeah, I can see this. It's grouped together here, right? So the metal is first. So I'm going to put zinc first, and then I'm going to put phosphate. Now, here's the tricky part, love. You ready? We got to figure out how many of each one there are. So zinc, we know is a charge of 2+ because we said that earlier. Phosphate is a charge of 3-. So how many of each do we need? That's the tricky part.
We need 2 phosphates and 3 zincs.
How'd you get there so fast? You did a great job.
Well, I know that they have to equal out, or the charges have to cancel out, which means they have to both equal the same number. So if I have 3 zincs, then that means I have a charge of +6.
Yes.
And then the other one, if I have 2 of them, that means I have a charge of -6, which then cancels out, making it even.
That's perfect. You did a great job. Last question. What phase is this? Zinc phosphate. Zinc, I don't see up here. Phosphate, I don't see up here. So which rule applies?
It's insoluble because all of their, wait.
Insoluble, what phase state? Insoluble equals what? Your choices are S, L, oh, no, come back. S, L, G, or AQ.
This is the part that I'm not sure on, like how to tell which
So
of them.
insoluble, so what is it?
Oh, solid.
Yep, tells you in the chart. It is solid, okay? Awesome. All right, you did a great job. Now, what else do we need to do to this equation? We did this whole equation. It took us all this effort. We did a great job. Jessica, what else do we got to do to it?
You have to balance it.
We have to balance it. So let's see how many on each side we have and balance it. So can you tell me how many we have on the reactant side of each type of ion?
Okay, so you have 3 potassium. You have 1 phosphate.
Good, and we always balance by the polyatomic ion because they cannot split up. They're stuck together forever. So they're always going to be together, so we count them together. All right, awesome.
1 zinc and 2 chlorides.
And 2 chlorides. And I'm going to put them on the same order on this side just for posterity's sake, so it's easy to compare. And thank you, Jessica. You did great. Charles, you're up next. Tell me the product side.
So 1 potassium, 1 chlorine, 2 PO4s, and 3 zincs.
Awesome. All right, so do you want to begin balancing that for me? Where would you start?
You would start in the potassium, and to make it equal, you would make it K3.
Yeah, so we do 3 here, and that would make this 3 as well. All right, I'm gonna ask someone else the next part. I think you're thinking ahead, but I don't want to be there yet, but you're doing a great job. So I'm stopping you. You're good. All right, Trisha, what next?
You need 2 PO4s.
Yep, so I put a 2 here, so that gives me my 2 PO4s, but what does that do to potassium?
It becomes 6.
So now what do we need to do to this guy?
2 more.
And we need to change it. We need to change it because he already has a letter and for our number in front of it. So instead of 3, what does our coefficient need to be?
6.
So we're going to make this 6 instead, and we're going to say 6 potassiums and 6 chlorines. Sometimes that happens. That's okay. All right. Stick with purple. Next up, thank you, Trisha. Sangeet, what do I do now?
You have 3 zincs on the product, so you have to put a 3 in front of the zinc on the reactant side.
And that gave me 3 zincs and 6 chlorines. So now this balances, this balances, this balances, this balances. So we have 2, 3, 6, 1. Also, Sangeet, I saw your email. I just haven't had time to respond yet. I will respond as soon as I can. Just so you know, because I saw your name. It's just my brain.
Thank you.
You're welcome. So 6, 2, 3, 6. These are now perfectly balanced. Now, scale of 1 to 10. At this point, we have not covered anything new, have we? This is all review. So this is stuff that we've been practicing for 2 weeks. So give me the scale of 1 to 10 in the chat. And if this still looks like speaking another language to you that you are not familiar with, we have a nice broad base language in this class. So I can't pick one and just assume you don't know it, but pick a language you don't know. If it feels like that, then you need to come to tutoring because we need to know this. 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 Yes, I got the email about QC 7.1, Audrey. So just a blanket statement about that, guys. QC 7.1, there were like 56 of you that had the ghost QC for I don't know what reason. I honestly don't. I only published one. I did the exact same way I always do, but for some reason that one QC just went a little cray-cray on the back end. Probably like the internet cut out, and so it published twice, like because it fixed itself, but I didn't know is what Canvas thinks. So I'm still working through them. I was going to change them all today, but I have to bring my son to an emergency dental appointment because he cracked a tooth. So I will not be doing it today. He'd be fine. Don't get me wrong. It's a baby tooth. We just got to get it pulled. It's not a big deal, but I still got to go take him so he's not hurting. So we're going to be doing that. And then tomorrow I will update it. So I've seen your emails. If you sent me the screenshot of 7.1, you are good. So no panicking until tomorrow at midnight. Just give me a day. All right. Okay. Because I see a lot of people asking me in the chat. So just blanket statement. I hear you. It is not your fault. Canvas was weird and you're loved. It's okay. All right. So now that we have the balanced equation, we're going to use this balanced equation that we created to discuss net ionic equations. So, Kai, in math, what does the word net mean?
I'm not 100% sure. But
Okay.
I think it means like, I don't know how to describe it, but it's
Okay, let me help you out. Have you had a job or have you had a paycheck or have you seen your mom's paycheck or your mom, dad, aunt, uncle? Like, have you seen a pay stub before? Do you know what it looks like?
no, not really.
Okay, let me bounce to someone who has a job and has seen a pay stub. Anybody? Anybody here responsible and make money? Extra responsible. You all are very responsible. I didn't mean to make it sound like that. Okay, so basically, when you get a paycheck, you have gross pay and you have net pay. So gross pay, like what I get from Alan, like my pay stub, gross pay is every penny I earn. So like when Alan hires me and says, we're going to hire you for X money per year, which is public knowledge. You could look it up if you wanted to, but I make X money per year, right? That is my gross pay. That's every dollar I am agreeing to earn. Okay. But that is not what they deposit. What do I got to pay? I got to pay the man, right? I got to pay my taxes. I got to pay my health care. I've got to pay for my retirement plan so I can retire and not teach forever with you crazies and whatever else, right? Just kidding. I love teaching, but I don't want to do it when I'm 80. So after they take all that stuff out, that is my net pay, is what's actually deposited. So the definition of net, Kai, I'm going to come back to you. The definition of net is what is left over. What is left over? What actually matters? Like my gross pay is great, but what I want to know at the end of the day is how much is getting in that bank account? What do I budget with, right? The net pay to me is what matters. That's left over. Okay. So with that in mind, what do you think the word net ionic equation means? What could that possibly mean?
I think it means like, okay, so like with the law of conservation and mass, in mind. You can't really have anything left over. But I think
Well, you can, and law of conservation of mass does come into play, but not the way you're defining it in your head right now. So you on the circle in the drain's a little wide right now, right at the top. Zero in, you're good. Any other ideas?
I think in the notes it said something like something that like cancels out in both sides of the equation or something like
Has
that.
something to do with it. So there's 3 words: net ionic equation. So if it's an equation, a chemical equation, what is it going to look like generally in very general terms?
There's going to be like elements or compounds on both sides.
There's going to be elements, or there's going to be an arrow.
Yes, the yield.
Reactant. And you said elements, compounds, ions. I'm being super general on purpose. I know I'm being super vague and it's frustrating. And there's going to be products that are the same, right?
Mm-hmm.
So this is what we know it's going to physically look like. It's a chemical equation. What does ionic mean, do you think?
Ionic? It's
Net
like
ionic equation. Yep.
Isn't it like a type of compound? So
yeah, it's a type of thing, right? It's an atom charge. So we know that ions are going to be on the left and some version of ions may or may not be on the right. So it has to do with ions, right? It's not only going to be ions, but we know that we're going to have ions somewhere. And net means it's what's left over after we cross everything out. So in this reaction, do I have any ions? That's a really weird arrow here. Let me there we go. Do I have any ions?
I mean, if you're like defining it as like a single element or like atom, I guess, then no.
Yeah, so ions are a single charge element. So let me ask you this. What type of bonding? So what type of bonding is this? What compound is this? Metal, non-metal?
Metal.
This is a metal. What is this group?
That's a polyatomic ion. Oh, non-metal then.
Yeah. Metals plus non-metals is what type of compounds?
Ionic.
Oh, where did the word come from?
Ionic,
right?
Wow.
So we
Yeah.
have ionic compounds. We have ionic compounds that we're going to have to cancel something out on the left and the right side, and it's going to look like a chemical equation. So I'm showing you that you know more than you think you do, and I'm making y'all use your brain space with questions you can't Google because you guys don't use your brains enough, and they're very good brains. Like you have some solid brains in this class. Like the blessing and the curse of the internet is I'm almost glad I didn't have it when I was in school because everything would have been too easy to find and the temptation would be too big. I get really annoyed when I hear teachers be like, oh, I would have never done that in school. I'm like, yes, you would have. Don't you even lie. If you were stressed out and you had an assignment due, you would totally be tempted. Don't you act all like above everything. Like the first thing we do in PD is we don't want to answer these questions and we're adults. Like it's normal to have the temptation, but I didn't have the temptation. So I was forced to develop my brain. Does that make sense? Like, I want you guys to ask yourselves questions you can't look up so that you can also develop your brains. But Google is also a beautiful thing. So I'm glad you guys have the internet. I don't want to make it sound like that. So, so when we're doing the net ionic equation here, the last piece we have to understand, I'm going to quit picking on Kai because I asked her all the weird questions. Bob, what does dissociation mean? Dissociation.
Isn't it when they break up into like electrolytes?
Yes, electrolytes, which are ions, right? In which type of phase does that? Solid, liquid, gas, or aqueous?
I think it's aqueous.
Yes, aqueous means dissolved or dissociated. You did perfect, all right? So in this chemical equation, next person, Jimin, in this chemical equation, which compounds are going to dissociate or are in a dissociated state in the beaker right now?
KCl and zinc 3.
Okay, so this one is because it's aqueous. What else?
And then the solid one.
The solid one, will it dissociate though? If it's a solid, does it dissociate in water? When you put, if you dropped a bullet in water, would it dissolve?
No.
No, that because it's a solid. Do you hear my question now? So will a solid dissolve in water?
No.
So this one is not going to dissolve, okay? Aqueous will dissolve. So which other ones will dissolve?
Other aqueous.
Yes, I know it sounds general, but I'm repeating myself so you hear it a lot of times, okay? All aqueous things dissolve, all solid things don't. Now, we're gonna take a walk back down memory lane for a second. Jimin, you're good. Megana, what did this mean in our notes last time? The dissociation reaction, what did that mean?
It was like the reaction when you split up the compounds, right?
Yep. So let me ask you this. Why do you think I taught you a dissociation reaction?
To prepare for this.
Yes, it's like I have a crazy mad plan and it all circles in on each other. I'm not as psycho as I sound, right? So all we're doing with these aqueous for net ionic is dissociating everything aqueous. If it's aqueous, we dissociate. If it's solid, liquid, or gas, we do not dissociate because aqueous means dissolved. So in that beaker, it's water plus those ions free floating, right? So let's practice dissolving things and doing dissociation. So each individual compound is an individual dissociation, which you already practiced last class. You did a great job. So Renee, let's dissociate potassium phosphate for me. Can you dissociate that for me, this guy?
So you would split it into six potassium and 2 phosphates.
Yeah, what is the charge on potassium? Because remember, these are ions. So
sorry, give me.
we got it.
1 plus.
Yeah, 6K plus, and that's what phase?
Aqueous.
Aqueous. Now hear me out. If you do not put the phase states in these problems, you will not get them right. Period. End of story. That's all she wrote. You must put the phase states because things that are not in the same phase cannot cancel each other. So if you don't know what phase they're in, you're already lost. You can't cancel something unless it's in the same phase. Perfect. All right. What else is in this?
Phosphate.
How many of them?
2 phosphate, and it's 3 minus.
Mhm.
And then also aqueous.
Yes. So to break it down for me, why did you say 6 and 2? Because you are correct, but you didn't explain why. And again, there's some people who haven't been here. So can you explain for the people who haven't been here?
There's a 3 next to the potassium, and then the 2 in the front distributes to both the potassium and the phosphate.
Yep. And then this only has 1. So there's 2, right? Because this whole group goes together and there's only 1 of them. Okay, awesome. Let me erase all that because that made that real confusing. All right. So that was the first one. Awesome. All right. What's next? Renee, you did a great job. Milan, what's next?
We have to dissociate the zinc chloride
Okay, why did you choose to dissociate the zinc chloride?
because it was aqueous.
Because it was aqueous, so walk me through it.
So it'd be 3 zinc, so Zn3.
All right,
and
3 zincs and what charge?
And then it would be a 2 plus charge.
Okay, and what phase?
Aqueous.
Okay, plus what else?
Then it would be Cl 1 minus as a charge.
What phase would those 6 Cl1 minuses be? Because 3 times 2?
It would be aqueous.
It would be aqueous. Lovely. All right, next up. What do I do next? What do I do next? Audrey, what do I do next?
Do you like set up like the sorry, you like add them to find the product?
Yeah, so we have the product right here, right? We have that product. So we split up the first aqueous, we split up the second aqueous, we put our yield arrow where it matches the yield arrow, and then we've got to do what to this guy?
Balance it?
Well, we got to, it's aqueous, right? So what do we got to do? Everything that's aqueous, what have we been doing to the aqueous things? This was aqueous, the first one. What do we do to it?
Like split it up?
There we go. So split it up for me.
Just 6K and then 6Cl.
What's the charge on K?
Positive.
And what's the phase?
Yeah, aqueous.
And then what about chlorine?
There's 6 chlorine, and that's and then I think that also has a positive charge.
It's -1 because it's group 7. And if you're doubting it, where could you look? What has all the charges in it?
Reference packet.
Yes, the reference packet will have it, and that's the 6Cl minus, and everything that started aqueous continues to be aqueous. Now, last one, you did a great job, Audrey. Thank you so much. Kiera, what do I do now?
Then you just write the zinc phosphate.
Why do I
because
just write it? Why aren't I not splitting it up?
Because that was the solid one, so it can't dissociate.
It's the solid one, so it can't dissociate, so it stays solid. I ran out of space. I always run out of space. It doesn't matter how small I write. This thing doesn't let me write small enough. Okay, so ran out of space. Awesome. So you did a great job. So Dia, remind me of what I said net ionic equation meant. What did net ionic equation mean?
When something changes.
When something changes, so it's only the part of the equation that's left over after we cancel everything else out. It's the part that changes. So what do you think we cancel out? Here's my yield arrow, right? So we're looking at things left to right like usual. So we're comparing left to right. What do you think I could cancel out?
The 6 potassium.
Why do you think I can cancel that out?
Because there's one on the reactant side and one on the product side.
So look at 6K plus aqueous, 6K plus aqueous. Those are the exact same. So are they reacting? No, they're staying the exact same state in the exact same conformation. No electrons were exchanged, nothing changed. So therefore it's not part of the reaction. Awesome. Under that definition, thank you, Dia. I'm going to call on someone else. Who else could I cancel out? Are you there, you? There we go. I see you're here. Your mic is really quiet. I see that you're unmuted, and I can barely hear you, friend. Yeah, it'll be 6 chlorine. That got a little louder at the end there. Thank you. Go back. So 6 chlorine is exactly the same on both sides. Therefore, it's not part of the reaction. Corey, can I cancel anything else out?
I don't think so. Well,
Are these two
no.
phosphates? Does it look the exact same on this side? It has to be this exact phrase.
No.
So everything in between the plus signs has to be exactly the same. That's why I made the plus signs a different color. So the plus signs, everything in between the plus signs has to be the same. It's not the same. This is not the same, and this is not the same. So how would you write your net ionic equation here? Go ahead, Corey.
1 second. I'm getting, okay. You would write the different ions, I guess, that you had.
That's left over, hence the word
Well,
net.
yeah.
So what is it? What is the net ionic?
2 PO4, 3 minus, it's aqueous.
Perfect.
Plus 3 zinc, 2 plus aqueous.
Okay.
Equal, or not equals, but arrow, and then
Yields. The word is yield. You're good. Most people say arrow. It's yield. Yields.
and then zinc 3 phosphate with 2, and then it's solid.
Yep. This is the net ionic equation. It's everything left over. It's who's actually making the reaction happen. This is a chemical reaction because of this part. Okay. All right. Something changed. So, no, you're not here today. Try again. You're not here today. Carter, if you are a spectator at an Allen High School sporting event, what is your role?
To watch the game.
To watch the game. So do you play sports?
No, I'm in the band.
You're in the band. Perfect. That still works. Okay. So you still do something on the field, right?
Yeah.
You actually participate in what's going on in the game. People come to watch you and the football, right? Hopefully. Because they're awesome. Right? So would you be a spectator or not a spectator?
I would not be a spectator because I'm
You would
involved.
not be a spectator to halftime because you are involved in halftime, right? So you are actually doing the thing, right?
Right.
Everybody else that's not in the band at halftime would be considered a spectator. So if you had to, thinking of the definition of spectator in events, right? Who would be the spectator ions here? Who is not participating but is present?
Would it be zinc phosphate?
So zinc phosphate this is in the game. This is what's participating. The net ionic is the actual play that's happening. It's what's being watched. What is being watched, right? So it's in the game. EA Sports, whatever. Sorry, old thing. If you've played the games, it happens. So net ionic equation is what is being watched. Zinc phosphate is what is being watched. So it cannot be a spectator. Try again. What do you think a spectator is?
Is it the chlorine?
One of them is the chlorine. It's just the identity of the spectator. What would the other spectator be? Who else just watched and did not participate?
The potassium by itself.
Yes. So potassium and chlorine were crossed out because they did not participate in the reaction. Therefore, they are spectators. They are watching the reaction happen. They in the beaker, they chillin', but they're not participating. They are watching. They are spectating. Spectator ions. Scale of 1 to 10. Scale of 1 to 10, guys. You're about to try one on your own, and then you're about to do group work after that. I'm out of water. No. It's okay. I have more. I have an addiction. It's a problem. Yes. Can I explain again how you can tell who's going to not be in the game? People who are not in the game are the exact same on the both sides. They entered the reaction a certain way. So like K plus entered the reaction aqueous. K plus exited the reaction aqueous. It looks the exact same on both sides. It is not participating. That's why we cross it off. Anything you cross off is a spectator. Anything you don't cross off is in the game, is in the reaction. It's participating in the reaction. Those are the net ionic equation. So if it's not in the net ionic equation, it's a spectator. Does that answer your question for the person who DM'd me? Okay, while they're doing that, here's another one, all right? It was crossed off because it was the exact same on both sides. Therefore, if it was the exact same on both sides, it didn't react because the definition of reaction is it changed from reactants to products. It did not change, so we crossed it off. All right, so this is another problem. Try to write, I'm gonna give you guys about a minute and a half head start. I want you guys to all sit and physically write this and try to make it happen without the Googles, okay? Give yourself a chance at trying to figure out where you get stuck. So write the balanced equation, create the net ionic equation, identify the spectators. I'm gonna give you guys about a minute and a half to 2 minutes of lead time, and then I'm gonna start asking questions, okay? So I'm giving you guys that minute and a half to 2 minutes lead time. If anyone has a question about the last problem while everyone else is working, now's a good time. But physically give yourself the chance. About a minute left. Get started, try to work ahead. About 30 seconds left to get ahead. All right. So magical wheel. Dun, 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 dun. Saya, S-A-Y-A, Saya. Where did you start? Are you here today, Saya? Am I talking to nobody? Saya, Bobaya. Oh, you're here. Ask to unmute. There you go. Oh, I see the chat blinking. I'm guessing you're there. Okay, all right. That's fine. I will call on someone else. Thank you for letting me know. Okay. Next up, Isabel Holden. How did you start?
I wrote down HCl because
Okay, so
it's
hydrochloric
hydrochloric acid.
Oh, go back. Hydrochloric acid you had as HCl. So what phase would that be?
Would that be aqueous?
Yes, because acids are hydrogen and chlorine dissolved in water, right? It's the hydrogen ion that makes it the acid part. So HCl aqueous. All right, what else is in that reaction? It got really quiet all of a sudden.
I'm sorry, magnesium, and that's solid.
Yes, magnesium, and that is solid. Perfect. Yields, and I'm going to pick on someone else now. Good job, babe. All right, Faisal, what's next?
Okay, so then it yields MgCl2. That's the first thing I did.
Okay, why did you decide that was a product?
Because it was so that we have like three players, I guess. So it was a single replacement.
Yep, and how did you know that the magnesium went with the chlorine?
I looked at the charges. So the Mg was 2+, and then the Cl was 1-.
Yep, positive replaced positive. Only positive, negative can go together, right? So I'm writing both ways that people remember it. So you saw that Mg as an ion is 2+, Cl as an ion is 1-, and that's why we had 2 chlorines. So we could have 2 negative and 2 positive to perfectly balance to 0. Perfect. And what phase was that? I started to write it and then realized I shouldn't.
Aqueous.
Why do we know it's aqueous?
So I was looking at the solubility chart, and Cl doesn't have any exception relating to Mg.
Yes, so it's Cl right here, and Mg is not in the exception, so it has to be aqueous. All right, so that's aqueous. And then what was your other product?
My other product was H2.
How did you get H2? Because that is perfectly correct.
Okay, so H was from the H from my reactant side.
Yes.
So I just used that and then moved it over, and then I tried to balance everything out. So my Cl had a charge, and then when I balanced it, I got H2.
Yeah. Can you send me the link again? Yes, I'll send you the link again. No problem. Yeah, but why did you know H needed to be diatomic and not a 2 in front of it?
H is just a diatomic element.
What are all?
It as H2.
Do you remember the phrase I taught you guys to remember them?
No, I just remember him.
Are you listening to mine? Are you listening? Are you?
I want to see what your phrase is.
So I said, have no fear of ice cold beer once you turn 21, or if your mom gives it to you.
Oh my gosh, no.
Yes, that's exactly how I remember, because the Cl is cold and the B are.
Beer is like BE. That's no.
No, beer, burr. Okay, have no fear of ice cold burr, because it's ice cold.
Ice cold burr?
I'm saying beer. I'm saying beer with an accent. Do you hear Harridan over here giving me crap? Whatever. Okay, legend.
You don't do Broncohoff?
Broncohoff.
I've heard that one before too.
No, I don't do that one. Oh, no, I don't. No, I did have no fear of ice cold beer once you turn 21, or if your mama gives it to you, because that's state Texas law. So H2, N2, F2, O2, I2, Cl2, Br2, those are the ones that have to occur as gases.
The hydrant way for our new house is so much nicer.
Oh, well, this is the way I remembered it from forever ago. They can have both now. They have yours in the notes and they have mine, and whichever one sticks, it works.
And then I also told them it makes a 7 on the periodic table.
It does,
because it's like group 7A.
Yep, because
I told them that too, but nobody listens to me.
No, it's definitely a 7, and it's because electronegativities and all the.
Because my students watch the videos with on mute, so
they watch the videos on mute. That's
so they don't hear anything I say.
That's so mean.
They don't even know I scream polo.
Audrey says hi.
I miss Audrey. I want her back already.
No,
I missed you too.
I stole her.
I want to trade.
You want to trade?
I got ones I want to get
They
rid
aren't
of.
baseball cards. I know they're squares, but they're not baseball cards. You can't just
Audrey's
trade
mine
them.
forever.
Audrey, whatever.
Yeah.
Whatever.
Yeah.
Suck it
we
up.
learned where
Buttercup.
the Trinity River was. That's all we need to know.
The Trinity River.
Yes.
Oh my goodness. Oh my gosh. See what I put up with? You guys see my job? This is why I have a retirement plan. I'm just kidding. So back to chemistry things. I love you,
I'll tell
Harridan.
you my retirement plan.
What?
I'll tell you my retirement
I would
plan
love to
because
hear your retirement plan. I'm pretty sure it's exciting.
It's pretty awesome.
Yeah, mine too. We'll exchange retirement plans. Oh my goodness. See, teachers have fun too. We all friends. Yes, if you wrote, so back to actual chemistry. If you wrote 2H and not H2, it would be incorrect. H has to occur diatomically, H2, and it is a gas. This is how it occurs as an element. This is the only way it occurs naturally by itself, okay? In terms of not being an ion, etc. So this is the way it is. The last thing we need to do is to balance it. So we have all our phases, we have our stuff. So Sonali, can you balance this for us? Coming back to reality for a minute.
So there's on the reactants, there's 1 mg.
Yeah. So
And
that
then-
one's good.
And then there's 1 hydrogen,
Okay, and how many are on the right?
2,
What do we need to put here?
a 2.
A 2 in front. That is a coefficient. So that gives me 1 magnesium on each side, 2 hydrogens on each side, and then this has 2 chlorines and that has 2 chlorines. So that figured it out. So it's Mg plus 2 HCl yields MgCl2 plus H2 gas. All right, scale of 1 to 10 so far. I love that this is the class I record too. So now the recording has all of that nonsense in everyone. So we'll see who actually watches the recordings or not. Oh, that's so funny. Okay, so now we're gonna do the net ionic equation. So Adhish, which ones do we separate into ions? How do we know from our chemical reaction, which ones do we separate into ions?
The aqueous ones.
Aqueous ones. So we will be separating, we'll be separating this one. We'll be separating this one. Do we do anything to the other ones?
No.
No. So how would you start your net ionic?
It would be 2H2.
Okay, so hold on.
Oh, sorry, that's
Yeah, let's read left to right. Let's read left to right. Otherwise, it won't look the same for everybody. So we start with this one. So do we do anything to it?
No.
So we just write it as is. All right. Then what do I do next?
Then it would become this is the part where it gets stuck.
Yeah, it's the part where it gets dicey. This is the new part, new-ish. We did it before, but we're doing it again in a new way.
Then it would become 2H2.
2H. Now this is an ion, right? This is not an element by itself. So it's as it appears in this compound. So in this compound, is it H2? What did we do up here? Oh, we didn't do that up here. So how do we decide it was HCl? Cl is what charge?
-1.
So H plus, or sorry, I just said it. Dang it. What charge is H?
+1.
Yeah, it's H plus, and that's aqueous. You have to keep the phase states. If you do not keep the phase states, you will not get it right. Okay, what's the other one? Plus
2Cl
2Cl, and what charge does that have?
minus
Minus, in what phase?
aqueous.
Aqueous. Awesome. And what do I do now? I'm going to pick on someone else. Lucas, do the product side for me.
Okay, so for the product side, it's gonna be you split apart MgCl2,
Okay, so Mg is going to turn into what?
Mg2 plus,
Mm-hmm. And what phase?
I'm not sure.
So if we're-
Aqueous?
Yeah, it's if
Does it
it's
stay aqueous?
yes, these have to stay the same as what they
Oh,
were.
okay.
We're presenting them a different way. Yes. So aqueous plus.
And then Cl2 1 minus.
Well, why is there two of them? How many? So if we put the two, do we put the two on the subscript, or where do we put the two? There's only two of these because there's two of these, right? Remember?
Oh, okay.
So we would put 2Cl minus, and it would stay that aqueous. What's the
Yeah.
last thing I write?
H2.
Last thing I write is
Or the 2H.
yeah, it's 2H gas. Does this dissociate?
No, it doesn't.
No, this does not dissociate either, which is why it stayed the same. Which is why it stayed the same, right? That's why I kept them yellow. Now, when we're trying to decide what to cancel, it's, oh my goodness, I'm gonna lose my mind. I don't know what's going on with this today. All right, so must be low battery. I'll plug it in. All right, so everything between the plus signs has to be the same for you to be able to cancel it out. And that's why the phase matter. You can't cancel a solid with an aqueous or a gas with a solid or whatever else. So at this point, we have someone else cancel things out. So Samir, what do I cancel out?
We're gonna have to cancel out the hydrogen.
So the hydrogen, this side is aqueous and this side is gas. Can we cancel that out? Does everything between the plus sign look exactly the same? Like you control C, control V?
No, it's not. So we have to cancel out the chlorine.
Yes,
because
the
that
columns
just is.
look exactly the same. The magnesium does not look the same. The H plus does not look the same. The Mg2 plus does not look the same, and the H2 does not look the same. So when I finish my net ionic equation, I have Mg solid plus 2H plus aqueous, because it's everything that's left over after we crossed off the others, right? Mg2 plus aqueous plus H2 gas. All right, good job, Samir. Last question for this one. Victoria. Victoria C. What are the spectator ions? Ions. Should have done that. Who is not participating? Are you here? No? Okay. Evangelina, who are the spectator ions?
Would it be Mg?
So Mg is in the net ionic equation. So if it's in the net ionic equation, it is what's actually reacting. It is in the reaction, it is participating. You're
Oh,
participating.
it would be
Yeah, go ahead.
2Cl.
Yeah, it'd be the Cl minus, just the identity of it. The Cl minus is what we crossed off. It is not in the net ionic equation. Therefore, it is spectating. This is what's boxed in blue. That is the game. Anything not in the game is spectating. Okay. For the individual elements, you do not, because they are not ions. So for magnesium, it says a piece of magnesium is dropped. That is a solid piece of magnesium in its elemental form, right? When it then gets dissolved or when it bonds with chlorine, it is exchanged electrons and becomes something new that can dissolve. That's why they're not. Mg2 plus is a magnesium solid that lost 2 electrons and therefore now does not have the same the atomic symbol. Mg is the same, but if we did the isotope notation, it would not be the same. The charge would be different. It's a different identity of the same ish thing, the same number of protons. Does that make sense? But other things are different, so they are not the same. The exchange of electrons is what defines a chemical reaction. Okay, awesome. Now you guys have a chance to show me you can do it. That was an extra stoic problem just in case, but we spent longer on the other things. So I want everyone to go to Canvas. Where did my Canvas tab go? I had it up. Nope. Is it here? Yep. Okay. So for Canvas, go back. Okay. If you look in week 19, I did not publish week 20 because you guys are still working here. I'll publish this after class day. So week 19, you see in class net ionic practice B day. I want you to click on that and I want you to open the Jamboard. Okay. So that Jamboard has 2 practice problems on it. Okay, it has 2 practice problems. Looks like this. So to go back and forth, you use these arrows. I accidentally clicked it 1 extra time and it gave an extra slide. It's no big deal. So you have 2 problems. You're going to work on them in groups. Okay, you have to give me the balanced equation, net ionic, and spectator like we just did. If you guys get done, you will send a group captain to come. Okay, you'll send a group captain to come. And as you see, I'm making your rooms. Your group captain will be one of your 5 people that will come and check your answers. If your answers are correct, your group will be dismissed. If your answers are incorrect, your group will not be dismissed until 1 o'clock. Everyone will be dismissed at 1 o'clock. That's the maximum it can run. The average time for people to get this done has been 10 to 15 minutes. So you guys should be able to get both problems done if you have really good examples. So I'm coming back. One person, team leader, okay, will come back and check your work for that Jamboard. All right, go to your breakout room. Do your thing. Go to your room. Ha.